In this video, I have 4 proofs lined up, and I'm going to walk you through each one just so that you can continue to hear the different logic and the different strategies that goes into putting these proofs together. All right, what I want you to do throughout this video is when we get to a proof, pause the video and try to go as far as you can on your own. Try to complete it if you can. But if you get stuck or if you think you've got the answer, then press play and see how close your answer matches mine. As we go through this, pay special attention to notation. All right, you want your notation to match mine because this is geometry. All the little details count. Before we get into the proofs, I do want to point out these 2 strategies. Now you have both seen me and heard me use these. I use these strategies pretty interchangeably, but these are the 2 big ways that you can approach a proof. The first way is just going forward. In this method, you pretty much take each piece of information and then ask yourself, what does this tell me? What information can I conclude from it? All right. And an example of this is saying that if angle C is a right angle, going forward, you could say if angle C is a right angle, then I can conclude that the measure of angle C is equal to 90. Okay, so you take what information you have and you draw a conclusion from what you have. Now, strategy number 2 is when you go backwards. This is when you look at the proof and ask yourself, what do I need in order to get here? So let's say to use the previous example, let's say you were trying to prove that the measure of angle C is equal to 90. Okay, if I was going backwards on this, something I could say is, in order for the measure of angle C to be 90, then angle C would have to be a right angle. Okay, what can I do in order to see if angle C can be a right angle? Okay, so it just depends on the picture. It just depends on the situation. There will be some days and some proofs where I will go forward because I can see how each piece of information leads to another. And then there are other proofs where I go backwards, where I look at the proof and go, okay, in order to get there, what do I need? In order to get there, what do I need? So, whichever way is your favorite, and honestly, you will probably use both of these in the same proof at some point. So just be aware that these are the 2 biggest strategies you have. Okay, that being said, let's get on to the actual proofs. Now, as a reminder, what I want you to do is pause the proof, or pause the video, and then try to do this on your own, as far as you can get, or even finish it. Then, once you're done, or you're stuck, press play and see how well we match. I'm assuming you have paused and come back, so let's get started. First off, drawing my T. Make sure you have your setup, please. The T is one of the basic ways and the silliest ways in which to lose points. All right, first I'm going to write is my given. And then I'm going to annotate my given. So RP is congruent to TQ, and then PS is congruent to SQ. And I need to get that RS is equal to ST. And I'll do it in different colors so you can see where we're going. I need to prove that RS is congruent to ST. Now, looking at my picture, as I'm thinking about how I'm going to do this, I notice that RS and ST are whole segments, and that these little bitty pieces, the pieces of each whole segment, are congruent to each other. So right off the bat, I know I'm probably going to have to include the segment addition postulate in here somewhere. So I'm going to go ahead, I'm going to put that in my proof. That way I have all my information that I need up front. So I have RP plus PS, is equal to RS, and then TQ plus QS is equal to ST. And this is a segment addition postulate. Okay. getting closer. So now I need to eventually get the whole pieces equal to each other. But right now, I don't know anything about the whole pieces, the whole segments. I only know about the parts. So what I'm going to do is I'm going to build the equation with the parts. Okay, because I know that RP is equal to TQ. And I know that PS is also equal to QS. And I can write this equation, I can build this equation with the addition postulate. Okay, because all I did was added the equal pieces to each side of the equation. Now that I have my equation, I can substitute my wholes in for their corresponding equations. So I have RS is equal to ST, and this is the substitution property. Last thing I'm going to do is double check and see if my last line matches my proof, and it does. So that being said, I can sign off and move on. Okay. If you have any questions on this, make sure to ask in class. But otherwise, let's move on to the next one. So if you're going to pause, do so now. I've assumed you've paused and are pressing play again. Here we go. So on this one, we know that angle 2 is supplementary to angle 3, and this is my given. Now, off the bat, I notice that I have a vocab word of supplementary. So I'm going to go ahead and use that vocab word first. So definition of supplementary angles means that these two things add up to 180. So I have the measurement of angle 2 plus the measurement of angle 3 is equal to 180 by the definition of supplementary angles. With this proof, make sure you're paying special attention to your notation. We're talking about the measures of the angles. So don't lose them. Okay, so what we're going to do now is we're going to back up, and I'm going to be going backwards, using the backward strategy to see where I need to go. I need to get that angle 1 is congruent to angle 3. So over here in my picture, I'm just going to notice things. The first thing I notice is that angle 1 and angle 2 are also supplementary, which means that over here, the measure of angle 1 plus the measure of angle 2 will also equal 180. And I can use that. So I'm going to go over here and I'm going to put it in my proof. So the measure of angle 1 plus the measure of angle 2 is equal to 180. And I know this because of the angle addition postulate. Okay, I'm adding up the measures of the angles and they equal 180. Now that I have my two equations, I can put them together with substitution. Okay. Now, I have the measure of angle 2 in both equations, so before I can take that out, I have to first say that even though they're in two places, in two equations, the measure of angle 2 does still equal the measure of angle 2 because of the reflexive property. And then I can subtract it out, and I'm left with the measure of angle 1 is equal to the measure of angle 3 because of the subtraction property. All right, I'm getting closer, but if you look at my proof right now and what I'm trying to prove, I'm not done yet. I need the congruency symbol, and I don't have it just yet. So what I'm going to do is I'm going to get it. I'm going to say angle 1 is congruent to angle 3, and I can do this because of the definition of congruent angles. Okay, remember, the definition of congruency and congruent angles changes from equal signs to congruency symbols, and then from congruency symbols to equal signs. Now the last line of my proof matches what I'm trying to do. It's good, and I can move on. All right, proof number 3. This one uses perpendicular lines. So we learned this one a few days ago. All right, so pause the video, see what you got. I'm assuming your plate again. Here we go. So I'm going to start off by saying that our line segment AB is perpendicular to line segment BC. Again, don't forget your notation. Make sure you have those little line segment notations on top of your letters. And this is my given. Now, perpendicular lines, I have that symbol. I'm going to go ahead and use perpendicular lines, use the definition of perpendicular lines to get to an equation. So I know that if these two lines are perpendicular, then angle ABC is a right angle. And I know this because of the definition of perpendicular lines. Okay. Then, because this is a right angle, I now know that the measure of angle ABC is equal to 90 because of the definition of right angles. So I had to go through 2 rounds of definitions in order to get to an equation. All right, now I'm going to pause, look at my proof and my picture. The place I'm trying to prove that angle 1 and angle 2 are complementary, which means I need to prove that angle 1 and angle 2 add up to 90 degrees. And well, I look over at my picture, and I see that angle 1 and angle 2 both add up to my big angle, which I just said is also equal to 90 degrees. So that's a good direction. I'm going to go in that way. I'm going to go that direction. So first thing I need to do is get angle 1 and angle 2 in my proof. I'm going to do that by using the angle addition postulate. So I have measure of angle 1 plus the measure of angle 2 is equal to the measure of angle ABC. And that's my angle addition postulate. Now I have measure of angle ABC. I can substitute that in for 90 degrees. I have the measure of angle 1 plus the measure of angle 2 is equal to 90. I did that by substituting. And now I can say that angle 1 and angle 2 are complementary because of the definition of complementary angles. All right, last proof. This one is on vertical angles. And it's another one we learned about last class. So go ahead, pause the video, see what you got. All right, here we go. So first I have angle 1 is congruent to angle 3. This is my given. I'm going to annotate my picture because that might help me. So angle 1 is congruent to angle 3. Now, looking at my picture, I notice that I need to get to angle 4. And look at my picture, I notice that angle 1 is vertical to angle 4. And because of my vertical angles theorem, I know those two are going to be congruent. So I'm going to put that in my proof. I know that angle 1 is congruent to angle 4 because of my vertical angles theorem. All right. Now I have that angle 1 is congruent to angle 3, and I have that angle 1 is congruent to angle 4. So I can now say that angle 3 is congruent to angle 4 because of the transitive property. All right. And that matches exactly what I'm trying to prove, so I'm done. All right, I hope you did well on all of these proofs. I hope you got as far as you could or that you understood what you were doing. Last but not least, here are some other tips. I've said these as I've gone along, but now they're written out. Number 1, get as much partial credit as you can, please. Always write your given. Always use proper notation. Always have your T-chart. Always sign off. These are things you can do that will guarantee you credit, because if you don't have them, you can guarantee I'm taking points away. So get as much partial credit as possible. Do the little things. Next, know your vocab, theorem, postulates, properties. If you do not have flashcards by this point, you are behind in the times. Get going on those. Okay? Plan your proofs. Look at all your examples, see the patterns, practice the patterns, reread them. Okay? When you're doing them on a test or a quiz, I mean, every single proof, you saw me pause and just think through what I need, where I could go, what I could do. Do that as well. If you got to make notes off to the side, more power to you. Okay? Then check your proofs. Always pause and make sure everything is logically sound. Make sure that you've included everything you need. Make sure that last line matches your proof. And make sure you did not lose anything like notation, the sign-off signal, all of those things. Okay? And finally, if ever you get stuck, always ask yourself, how should I know this? How do I know this? Okay, if you say that two things are congruent, well, why are they congruent? And that should help you catch a lot of those in-between steps. Okay, well, I hope this was helpful for you. I will see you next time in class.